Welcome. This is Coach Dorf. We're in section 3.6, and we're looking at a homework-like example. In this example, we're finding the derivative of y equals x to the 1 over x power. So we look at this. We have y equals x to the 1 over x power. What's unusual about this problem is we have x's in the exponent, and we have x term in the base. Whenever we have a situation like this, we use logarithmic differentiation. All right, logarithmic differentiation allows me to take that exponent with the x variable in it and bring it down to the same level as the base, and then I can do the derivatives. So to start this problem, the first thing I would do is take ln of both sides. All right, so then I have ln of y on the left side, and I have ln of x to the 1 over x power. How does that help me? Well, now I can use one of my properties of logs that says that if I have the log of something with an exponent, I can bring that exponent out front. So this is then going to be equal to 1 over x times natural log of x. So see how we've gotten the exponent term down onto the same level as the base term with the variable x. Next, then we take d dx of both sides. So when I do that, I have d dx of the left side, which is natural log of y, and we have d dx of 1 over x times natural log of x. Now on the left side, because I have the y variable in there, I'm going to be using implicit differentiation. And so when I do that, I take the log, the natural log of y, I take its derivative, I get 1 over y. But because my variable term there is a y, I'll have a dy dx expression there. On the right-hand side, we have the normal parts with the x's in there. But notice that when I'm doing the d dx, I have 1 over x times natural log of x. So I have to use the product rule. So I have to use product rule because I have that multiplication there. So the product rule says it's the first times the derivative of the second plus the second times the derivative of the first. All right, so left side, now I'm going to keep that the same. And now on the right side, I'm going to take those derivatives. So I've got 1 over x times the derivative of natural log of x. And the derivative of natural log of x is 1 over x plus ln of x. And then I have the derivative of 1 over x. And what's the derivative of 1 over x? Well, that is negative 1 over x squared, all right? How do I get that? Just as a reminder here, dx of 1 over x. What I'm going to do there is I'm going to write that as x to the negative 1 power. And then I use the power rule, which says that I bring the negative 1 out front, write down the x, and subtract 1 from the exponent. Now the exponent's already negative 1, so negative 1 minus 1 is a negative 2, which then I could rewrite as negative 1 over x squared. All right, so that's how we got that term there. So now I'm going to go ahead and rewrite now what I have on the left side. And on the right side, now I have 1 over x squared plus, well, let's see, natural log of x times negative 1 over x squared. So from there, then what I want to do is I notice then that on the right side, I have a 1 over x squared on both terms. So I'm going to bring that out front. And then I have a 1 minus natural log of x. Yeah, remember that this second term there, it's natural log of x times negative 1 over x squared. So far so good. Now I have that 1 over y on the left side. I need to bring that over to the right side so I can just have dy dx by itself on the left side. So I'm going to multiply both sides by 1 over y, by y, so I get rid of that 1 over y. So then I have y times 1 over x squared times 1 minus natural log of x. And now I don't want to leave that y there. I want to have everything in terms of x if I can on the right side. And I can do that in these types of problems. And so I write dy dx. What is y? Well, if I go back to the very beginning of the problem, y was equal to 1 over x. X to the 1 over x power. So I write that in there for y, and then write down the rest, and I have this. And that's going to be my final answer. Hope that helps.